FastMCP implements a generative UI provider system through modular provider registration, enabling dynamic UI generation at runtime via a sandboxed execution environment. This architecture leverages the Model Context Protocol (MCP) to coordinate between the LLM's code generation and the rendering pipeline, ensuring real-time progressive visualization. We're about to examine the foundational setup, where a FastMCP instance initializes with a server identifier and registers the GenerativeUI provider, which automatically configures the necessary tools and rendering infrastructure for dynamic UI generation. The code demonstrates how this minimal configuration establishes the complete generative UI pipeline, including component discovery and sandboxed execution capabilities. From FastMCP, import FastMCP. From FastMCP apps generative, import GenerativeUI. MCP equals FastMCP Prefab Studio. MCP, add provider GenerativeUI. This code demonstrates the foundational setup for FastMCP's generative UI system, where the LLM dynamically writes and executes UI code at runtime. The pattern combines a provider-based architecture with sandboxed execution to enable real-time UI generation. The FastMCP class initializes the Model Context Protocol server with an identifier string, while GenerativeUI registers two key tools: Generate Prefab UI for code execution and Search Prefab Components for component discovery. The provider automatically configures the browser-side Pyodide environment for streaming rendering, creating a seamless pipeline from code generation to visualization. This approach prioritizes flexibility and real-time feedback, allowing the LLM to write arbitrary prefab UI code that executes progressively as tokens arrive. The trade-off is the sandbox limitation to built-in Python and prefab components, which ensures security but restricts access to external libraries. The design choice to use Pyodide enables browser-side execution while maintaining server-side validation for safety. Let's break it down line by line. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core implementation for Model Context Protocol MCP server functionality. The imported class will be used to create MCP server instances, with the string parameter serving as a server identifier visible in protocol handshakes. From FastMCP apps generative, import GenerativeUI. Imports the GenerativeUI class from the FastMCP apps generative module, making it available for use in the current scope. This class is specifically designed for generative user interface components within the FastMCP framework. MCP equals FastMCP Prefab Studio. Creates an instance of FastMCP with the server identifier Prefab Studio. The string parameter serves as a label for protocol handshakes, allowing clients to identify this specific server instance during MCP communication. No functional configuration or operational mode is set by this parameter. It's purely for identification purposes. MCP, add provider GenerativeUI. Registers a GenerativeUI provider instance with the MCP Model Context Protocol system. The addProvider method attaches the provider to the MCP framework, making its capabilities available for context generation tasks. This specific line demonstrates the integration of a UI-focused provider into the protocol's provider chain. The 4 lines establish FastMCP3's generative UI pipeline by combining a provider-based architecture with sandboxed execution. The FastMCP instance initializes the Model Context Protocol server with a simple identifier, while the GenerativeUI provider registers the necessary tools: Generate Prefab UI for code execution and Search Prefab Components for discovery, along with the browser-side Pyodide environment for streaming rendering. This minimal setup creates a seamless flow from LLM-generated code to real-time visualization, prioritizing flexibility and progressive feedback. The trade-off is intentional. Pyodide Sandbox restricts external libraries for security, but enables browser-side execution while maintaining server-side validation. The result is a dynamic system where the LLM writes arbitrary prefab UI code that renders incrementally as tokens arrive, all coordinated through MCP's protocol.
The server name whispers its identity to the handshake, then dissolves into the protocol's memory like a ghost in the stack trace.